It took me a long time to get good at coding interviews because every time I used to look at a problem, I would not be able to think of anything other than brute force solution. It took me 400 plus coding question practice to get any better at coding interview. However, you don't need to solve that many questions to get better at coding interviews. In this video, I'll cover 9 patterns that you can use to solve almost 80 to 90% of the LeetCode questions. My name is Akash and I'm a software engineer at Microsoft. Let's get started. Let's look at the first pattern. Two-pointer. Like the name suggests, two-pointer pattern can be used to iterate through a data structure till one or both pointer meet certain condition. Classic example for this is a two-sum problem on sorted array. Aim is to find two elements that sum up to certain target. You can set the pointer on the left and pointer on the right and keep moving each of the pointer till the target is found. Another not so obvious example that uses this technique is a maximum water area problem. In this problem, there is list of bars with separate height and your objective is to find two bars where the maximum water can be stored. To solve this problem, you can set the pointer on the left and pointer on the right side of the array and then calculate the amount of water that bar on the left and right can store. And then slowly move the pointer toward the middle in order to find out the maximum amount of water that can be stored. Next, let's talk about slow and fast pointer technique. This pattern is a slight variation of two-pointer technique. In this pattern, two pointers are initialized at start of the data structure. One pointer moves slowly, meaning one element at a time, and second pointer moves fast, meaning two elements at a time. Although this pattern can be used on variety of data structure, it is most commonly used to solve linked list related questions. Let's look at an example problem where this technique can be used. First, finding if linked list has a cycle. To solve this question, you can initialize slow pointer and fast pointer at the beginning of the list. Then slow pointer can move one element at a time, while fast pointer moves two elements at a time. Eventually, if there is a cycle in the linked list, then a fast pointer will catch up to the slow pointer. And when that happens, you know that there is a cycle in the linked list. Another example is to reverse a linked list from the middle. In this, you can initialize slow pointer and fast pointer and figure out the middle of the linked list, and then start beginning the reversing process. Next pattern that I'm going to talk about is sliding window. Sliding window is yet another variant of two-pointer technique. In this pattern, a window of fixed or dynamic size is established using two pointers, and all the calculation happens between that established window. Let's look at few problems that can be solved using this technique. Determine maximum sum of 3 consecutive elements. In this problem, a fixed window size of 3 elements can be created to iterate over an array. For each iteration, you will calculate the sum of the 3 consecutive elements and determine the maximum sum. Now let's look at an example problem where dynamic window size can be used. In this, a window of dynamic size can be created to keep track of the longest string where the characters are not repeating. Each time a repeated character is encountered, the starting window moves till there is no longer any repeated character in a string. Next, let's talk about frequency counter. This pattern is quite simple. It involves counting the frequency of elements in an array or string. Based on the frequency of elements, questions like most common element, least common element, or overlapping element between two strings can be found. In a medium level difficulty problem, this pattern will often be found in conjunction with other patterns that we covered. But easy questions like determining the most common elements in an array, or if the string T can be formed using the characters of string S, can be solved using this technique. Next, let's talk about binary search pattern. This algorithm is most commonly used to find an element in a sorted array. Often, questions can be twisted or questions can be asked where binary search will be used in conjunction with other pattern. For example, three-sum problem. However, questions can be twisted to implement a variation of the binary search. For example, search for an element in a sorted array that is rotated at certain index. If you want to become good at LeetCode, then you should be able to implement binary search algorithm in 5 to 10 seconds. Initially, it will be difficult, but once you implement it few times, you'll be able to do it in 5 to 10 seconds. Now let's talk about BFS and DFS. BFS and DFS algorithm is most commonly used to solve trees and graph problems. Whenever you get problems related to trees or graph, you can almost always implement BFS or DFS and it will almost always stick. However, BFS and DFS algorithm can also be applied on arrays and strings. Consider this problem. Find the number of islands in an array, or find the biggest island in an array. Both of these problems can be solved by implementing a DFS algorithm. See if you can figure it out. Apart from that, problems like cloning a graph or tree, iterating through tree, getting the right view of the tree can be solved using BFS and DFS. Next, let's talk about top k elements. Top k element involves problems such as finding nth largest element. Top k element pattern involves usage of heap or priority queue to keep track of order of elements. Problems like finding nth largest element or keeping track of nth largest element at any given time involves usage of top k element pattern. For example, problems like finding kth largest or smallest element in an array can be solved using this pattern. Another interesting problem that involves involves this pattern is finding the next hottest day. Next, let's cover subset pattern. This pattern involves creating permutation or combination from an array or string. Anytime the word subset, permutation or combination is used, it is likely that you can use this pattern. Questions related to subset can be solved using an algorithm called backtracking. It is a special type of recursion algorithm. Let's look at a few example questions that involves this pattern. Find all permutation of an array. Find all combinations of an array. Find sum of path in a binary tree that equals to certain target. Find combination of all strings. These are all the problems where backtracking and subset pattern can be used. And last, let's talk about interval merging. As the name suggests, this pattern involves merging overlapping interval or multiple data structures together. Problems that involve this pattern will have subarray containing two elements. Each element in an array would act as an interval. Expectation would be to merge overlapping intervals or append an interval. Or a slight variation like merging n-sorted arrays or n-sorted linked list can also use this pattern. Problems that involve this pattern can be solved using while loop and multiple conditions. Let's look at few example problems that involve this pattern. Merge interval. Here the expectation is to merge overlapping interval. Add an interval. Here the expectation is to add an interval and merge all the overlapping intervals. Merge two sorted arrays. Here the expectation is to merge two sorted arrays or linked list. Apart from this, there are other popular techniques that we have not covered, such as dynamic programming and greedy. However, I would recommend that you focus on the patterns that we cover in the video and get better at it. So what should you do to become good at identifying and implementing these patterns? Practice. You can start by practicing multiple questions that involve same pattern. With enough practice, by that I mean 5 to 10 questions per pattern, you will start to identify them. Eventually, you will learn to apply this pattern on completely unseen questions before and ace the coding interview. That's it for this video. Hope you found it useful. Please like, share and subscribe. As always, if you have any question, please comment below and I'll try my best to answer it. See you in the next one. Thanks.